Well, good morning, everybody, and welcome to the first of today's webinars from Smart Vision Europe. Today, we're going to start off the webinar day by looking at an overview of IBM SPSS statistics. Later on in the day, we're going to be looking at how to interpret significance tests in the second webinar, and a third webinar, we look at Bayesian statistics and how to make sense of those in SPSS statistics. So they do kind of link together, and you're absolutely welcome to join more than one. My name's Jarlath Quinn. I'm an analytics consultant. We normally have a few housekeeping points that we like to address at the start of these sessions. The first is that these sessions are recorded, so you'll be able to listen to them again afterwards. And there's some slideware here, not too much in this session, but definitely a few more slides on the subsequent sessions. But we'll email a link out to you so you can download the slides afterwards as an aid memoir. Now, with regard to any colleagues who are unable to attend, we may be able to arrange a rerun for colleagues if you get enough of them together. The best thing to do is just drop us an email or something like that, and we'll see if we can arrange that. And also with regard to asking questions, all the lines are muted, so we can't hear you, but we ask you to use the chat panel, and we'll try and keep an eye on them as we're going through. But if not, don't worry about it. We will follow up with you offline afterwards. And of course, if questions occur to you afterwards, do feel free to contact us. Just drop us an email or something like that, and we'll address any questions that you might have. So if you don't know who we are, we're Smart Vision Europe. We're actually a technology company. We're a gold accredited partner to IBM, as well as companies like Predictive Solutions and Data Robot. And we specialize in statistics and data mining and data science and AI and all that machine learning and all that kind of stuff to do with analytics. Though we also work with open source technologies such as R and Python. Now, each team member, which is a relatively small organization, is made up of people who have some sort of experience working in the predictive analytics or software industry in the past. Most of us have worked for SPSS Incorporated. So this is the tool we're talking about today. And some of us have decades of experience. I started working for SPSS 30 years ago. And since then, I've worked for IBM and SAS as a consultant in a technical customer-facing role, talking about, statistics and data science, machine learning, and all these types of things. And that means that as a result, as an organization, we've got quite a lot of experience of applying advanced analytics and statistics across multiple different sectors, whether it be the commercial sector or the not-for-profit sector in areas like the media, manufacturing, insurance, retail. Very, very likely to have applied statistics in the sector that you work within. We can provide advice if you have questions around that. Let's start off talking about what we're going to go over in this session. First of all, we're just going to give you an overview of SPSS statistics, so you got a sense of SPSS statistics are. And what SPSS statistics, where it comes from. We'll also then look at reading data from databases and spreadsheets and formatting the data. Formatting the data is actually a generic term that we would probably use. It just basically means getting the data in shape so that you can do some analysis in SPSS. It's really important. It's one of the areas where people really struggle when they're trying to kind of download a copy of SPSS, open up SPSS, they read a file in, and they can't really get the results that they want out of the back of the procedures that they're running. It's usually because the data's not been formatted correctly. SPSS likes its data set up in a particular way. So we'll be spending some time talking about that. And then we'll talk about creating filters and creating banded or grouped fields, as well as using an SPSS module called the SPSS Custom Tables module, which allows us to create more complicated tabulation. Just to give you a quick overview of what that looks like. And finally, we'll look at, we'll touch upon finding statistically significant differences in groups. If this is of particular interest to you, then we would urge you to join the next session where we take a much deeper dive on statistical significance, what that means, and how it works in SPSS. So first of all, an overview of SPSS, IBM SPSS statistics. You should be aware that it's been around since 1968. And as a result, it's one of the world's most popular data analysis and statistical interrogation platforms. It certainly used to be the world's oldest software company. And certainly, a lot of the first software programs that were kind of made commercially available were around the area of data analysis, and SPSS was definitely one of those. And as a result of that, rather like Excel, where it's very hard to talk about a typical user of Excel these days. Once upon a time, a typical user of something like Excel would be an accountant. But nowadays, everybody uses it for everything numerical. In the same sense, in SPSS statistics, everybody uses it for everything from medical epidemiology studies to any form of survey research analysis and business reporting and marketing reports, that type of stuff, direct marketing, credit risk assessment. Process modeling is a type of modeling that's used in quality control and manufacturing, managing assets, machinery, that type of stuff, doing predictive models, finding significant differences, trying to estimate values, trying to forecast into the future. A really, really broad range, landscape of different procedures. So SPSS, as you will see, comes in the form of a base software package with some additional modules that can be added on to that. But just so you're aware, things that are included in the base software, so if you just had the basic copy of it, you would still be able to do things like manipulating the data, computing new fields. You'd be able to do cross-tabulation, frequencies, descriptive statistics. You'd be able to do a lot of different statistical tests like t-tests and correlations and basic ANOVAs. And you'd even be able to do predictive modeling like linear regression and multivariate procedures like factor analysis and cluster analysis. And despite the fact that that's quite a wide plethora of different techniques, there are many, many other techniques in the statistical realm that aren't included in the base. And as a result of that, there are these additional modules that tend to reflect the different areas that people work within. Currently, that's what all the different modules look like. You should bear in mind, though, that if you have a copy of SPSS, you may have something like SPSS Professional or SPSS Premium, which means that they've been bundled together. You can actually look on our website how to find out what modules you've got installed in SPSS. You can just run a little command in SPSS syntax and it'll list them out. But you would have modules like the regression module that would include more unusual forms of regression, like logistic regression or probe non-linear regressive techniques. And then procedures like advanced statistics really go into things like survival analysis, which is used a lot in medical research, complex samples, which is used by organizations like the Office of National Statistics, who aren't taking samples just based on random samples. They're doing quite complicated sampling procedures and used again in things like political surveys where you have very exotic forms of sampling and so forth and so forth. So if we were to pick one of these, for example, something like the decision trees module, what would happen is that you just get access to this procedure and it would appear as an additional dialogue in a menu. So it would just appear as a different option in the menu. And decision trees, again, very, very useful. We would urge you to look into it if you haven't heard of these before. Um, a very useful way to build predictive models, a way to create profiles of people, to actually see profiles of people who are most likely to do something like respond to an email or most likely to recommend to a friend or most likely to express satisfaction or dissatisfaction. And it works by finding key behavioral segments. And they're very popular because they represent these models very visually and they're relatively easy to understand. So this one here, for example, looks at survival on the Titanic. So we do a webinar specifically on decision trees. This would be an example, as I say, of a module. We wouldn't be in the base, but probably be in the professional package or the premium package, or it could be purchased or added individually to the base module. But here it's simply saying that people who males or females is the single biggest discriminator between survival and the Titanic. That's the single biggest factor that drives survival. Where only 21% of males survive and 73% of females survive. And more for the female group, the 470 female passengers, the next most important factor is the class that they travel in. You can see that second class and crew here is is grouped together because they're not statistically different from one another. If they're traveling second class or one of the crew, 87% chance of survival. Whereas if they're male, then the most important factor is, whether or not they're an adult or a child. And if they're an adult, then of the 1,667 male adults, the class that they're traveling in is most important. And it's a really powerful way for us to find exceptions to rules. For example, we find that the people who are least likely to survive were actually males who were adults traveling in second class, but only 8.3% of them survived, whereas in third class, 16% survived, and in first class, 32% survived. So this is kind of like building a profile. It's finding segments, and it's effectively a predictive model at the same time. So if you're interested in that, you should just Google Smart Vision decision trees, and you'll probably see a YouTube, or it'll take you to a previous recording of a webinar that we've done on that. Or alternatively, you can sign up for one of our forthcoming webinars where we'll certainly, in future coming webinars, where we'll definitely be covering decision trees at some point in the future. So this is an example of a module that's added to SPSS. There are lots of modules, as I say, and people are always somewhat kind of perplexed over what they all do because they have these names like decision trees, direct marketing, exact stats. So we created a really short 2-minute video overview of each of them on our website. You can go onto our website, click on them, and it will give you a little 2-minute overview of what's in each of these modules in case you're interested in that. Okay, let's return to our main purpose in this session, where we're trying to give an overview of SPSS statistics. And there are 3 things that we're really trying to touch upon here. And these 3 themes or these 3 topics reflect in many ways the 3 skill areas that anybody working with analytical software needs to be able to demonstrate. It doesn't matter if it's SPSS statistics or R or Python or Minitab or any of these tools you're using. If you're going to be useful, if you're going to be able to actually get to grips with analytics, then you're going to have to be able to read data in. You're going to have to be able to read data in and format data appropriately. So get it in, so into the system. And it might well be that is that you're reading data from a third-party format. It might be something that's exported from a system like, I don't know, SurveyMonkey, or it may be it's a CSV file that's been given, or it might be a Excel file, or it might be on a database, or it might be on the internet, or something like that. So reading the data and getting it into SPSS is the first sort of task that one would have. Next thing would be transforming and manipulating the data in some form. So trying to transform and manipulate the data, trying to recode it, or classify it, or recategorize it, or clean it up, do a lot of data cleaning, dealing with unusual values or mistakes. And the last area would be analysis and deployment of results, where we're really interested in, obviously the analysis that we do and how we get those results out into the wider world. So that might be something as simple as, copying and pasting a chart into another platform, or it might be, trying to export scores or numbers that you've generated through forecasting or through prediction or through some form of classification to a third-party system like a database or something like that. Okay, so let's start off by looking at SPSS itself. I'm just going to jump out here to my copy of SPSS. Here we have it here. So, and as you can see, it looks a little bit like a spreadsheet to begin with. I wouldn't try not to make that mistake of mistaking it for a spreadsheet. It doesn't work in the same way at all. And this version that I've got is version 31. That's the latest version. But really, you should find that the differences between each version, certainly from about the mid-20s up to 31 or 20, 25, 26, they're very, very subtle differences, okay? It's not obvious when you open it up which version you're looking at. They tend to add, with each version, tend to add a couple of little routines, a couple of little procedures, which are somewhat different from one another. If you want to find out the differences between each version, you can go into the help system, and there's a section that says what's new in version 31, and what's new in version 30, and what's new in all these different versions. So that's all, that's something which you should be aware of, that you can do that. Okay, I'm seeing some questions popping up here. I'm just going to have a quick look at them before going any further. We're still seeing the slides, not SPSS. Okay, Thank you. That is, we've just jumped. That's because on Zoom it tends to show the window sometimes and not the actual not the actual screen itself. So I'm just going to hit here and let's go share and go share screen. Sorry, rather than window. So share screen. Okay, that was useful. Thank you very much for interrupting me and telling me that because I didn't know otherwise. If I look at the chat again here, okay, so okay, I can see it now. Thank you. Okay, yes. So some of these are just housekeeping questions that people are asking. Okay, that's fine. So we have the spreadsheet type interface that we're looking at. And as you can see, it looks like any other Windows application. You have file, you have edit across the top here. Um, Something that you'll notice when you start working with SPSS is as soon as you start doing anything, you get this additional window opens up. This is the output window, and this is where the results appear. So if I was doing some analysis here, I'd need to get some data into this what's called the data editor, effectively a sort of worksheet. And as soon as I started doing anything to that data set, you'd see results starting appearing on a separate window, which isn't open at the moment because we haven't got any data in. And that window is called the output viewer. Now, you can have more than one data set open at the same time. I tend to switch that default off. Just so you're aware, if you go to edit under options here, you can see there's all sorts of default settings, so the preferences that you can set. I tend to check only open one data set at a time, simply because it can get confusing when you've got multiple data sets open at the same time. And that's why it gives it a little label here, just data set or data set one, data set two, data set three. So the first thing I'm going to do is I'm going to import some data. And I've got some Excel data I'm going to import first of all. So that's the first thing I'm going to do. So I'm going to go to File, Import Data Excel, as you might do just very naturally. Think about it. If I navigate to a folder here, I've got a workbook called Employee Workbook.xlsx. So you can read different types of Excel workbooks here. Lots of other different types of files as well. You should bear in mind CSV, text files, SAS files, data files, a range of different file types. But Excel is kind of a standard way in which people tend to send data and share data. So we'll open that. We click open at that point. It starts a wizard. Okay. And it automatically detects where the data starts and where it ends. And it automatically gives you a little preview of the first few rows here. So you look, you can see the first few rows of data here. And that kind of tells us that it's working, that the fields are being found correctly. They're in the top row data. If they weren't in the top row data, if you had a title or something like that, you might have to tell it that the field name started on the second row or the third row. It tries to guess what type of field it is. So by that I mean it tries to guess whether it's a number field or a category field. And that's what that box here says, percentage of values that determine data type. So it will use whatever 95% of the data or the values in a column to determine what that data type is. You can switch that off. You say, no, I want to use 100% of the values. And in string data and character string data, like names or addresses, or here we've got like M's and F's for males and females. It is possible you get some hidden characters like a leading space or a trailing space, and you can just ask it to automatically remove those by checking those two buttons there. And that I generally regard that as good practice generally, if you've got a lot of string data. If I click OK at that point, however, it will go off and read that data in. And what it's done now is it's just read raw data in for me. So it's read some raw data in, where you can see that some of the fields here, like gender's a bit squished. I could probably just straighten that out. I could move these around a little bit. I can see that some of them have decimal places when they probably don't need decimal places. For example, we have a field here called minorities, just 0 and 1. And we have education here, which is really an integer value. We have some values which are M's and F's, which are character strings. We have some values which are categories, it appears, but we just have number categories. And we have some values which are being read actually as correctly as in the format that they're being stored in, which is salary in dollars and birth date being shown as a date field. So it's done a pretty good job of reading that. If we didn't have Excel files, somebody else had sent this data on, say, or said told us to connect to data on on something like a database. We might go to import data here and go to database instead. And that starts a query wizard for us. If I click database new query, that loads what's called the database wizard. Okay, so and you can see here I've got some connections to databases set up. There's one here which is a large SQL database I've got, which has lots and lots of different tables in it. So databases are made up of multiple tables, so lots and lots of those I could select from. Alternatively, I could say, look, I've got little Access database. People don't tend to use Access anymore, but it's a shame because it is quite a good way to store data. I could say I've got a little Access database here, and it opens up a little dialog box saying, okay, search for that. And weirdly enough, when I open it up, it defaults to Excel types. I don't know why. It says types of file XLS, but if I switch down to Access here, it can see the Access database, and this one's called Employee. It's exactly the same file, or more or less exactly the same file as the previous one, which was in Excel. And here I've only got one table, but you could have multiple tables, and it would automatically join them together using a common key. If I dragged the multiple tables over, say you might have something like employee details and work history or something like that, and it would join them together for you. If I hit next to that point, it gives me the option to limit how many cases, because you might be a really big database and you don't want to read 10 million records. You might just want to read the most recent records, something like that. And it gives you the opportunity to rename the fields or to convert string fields into number fields. Got a lot of controls here. And finally, it says, okay, look, I can save this in a language that the database understands, like SQL, or I can save it in a language that SPSS understands, which is SPSS syntax. And if I hit finish at this point, um, it says, you want to save the current data set? I say, no, I'm not really interested in that. And it reads it in. Okay, so now we've got the only difference between this data set and the previous one is this one's got an additional variable here called age, which we'll come back to in a moment. But it looks like it's read everything correctly. And the first thing I want to do is I want to point out to you the importance of formatting again. So why formatting is important. So when you have data that's been read in the SPSS, if you just right click on any column, you can click on this option here. It says descriptive statistics, and that will immediately do an analysis and send some descriptive statistics to the output window, which is output viewer, which is here in the background. So it's actually got two windows open. It's got the data set and it's got the output viewer. And we can see here that we've got a field here called gender, F and M, labeled F and M, 45.6% are F and 54.4% are M. Why is that? Well, it's because they haven't been labeled, have been formatted. And if you notice at the bottom here, we have an extra tab here called variable view. And this is where we can go through each of the variables which are sorted as rows, and we can format them correctly. So for example, here I could change this. So instead of saying just gender as a column header in an output, I could say gender of employee. This is quite a famous data set. It comes from the 1980s in America, and it was used in a court case to prove equal opportunities court case to prove discrimination. So if I right click now on gender and say descriptive statistics, you can see that it's exactly the same as previously, except now it says gender of employee rather than just gender. So obviously if your fields are called something like Q.41 underscore B, which is what they're likely to be called if they're coming out of a system, a third-party survey system or something like that, you might want to rename them into something which is a bit more meaningful and to give them labels which are going to appear above the output. And the other thing you might want to do is you might want to make sure that instead of codes appearing, that you have little labels for the codes. These are called values and value labels. So F, as you can guess, will be female, and M, as you can guess, will be male. Okay, I'll click OK at that point. Right click now, run it again, and now we have that field that's been almost correctly formatted now. It says gender of employee, female, male. It's been correctly formatted. And this is what we do in SPSS. We try to front load our efforts and set up all the data correctly so it does analysis. Notice also that it's being sensible about how I about the type of output it's giving me. So it knows that this is a category field. It guessed that using the import default. It guessed that category field. Whereas if I went over here to salary and right-clicked on that, it guesses that's not a category field. That's called a continuous field. And it doesn't give me percentage breakdown. It gives me some summary statistics. Says the mean salary is 33,941. The median salary is 28,500. And the range goes from -1 to a maximum of $135,000. Well, there's a few things we have to do there to fix that and to deal with this. First of all, is I could tell it that this is actually in dollars by changing the type to dollar. I could do that for the next field down as well. And you should be able to copy and paste these between one and the next. You can kind of copy and paste them, but there's that. Sorry, that's date. I don't want that. I want dollar. Change that to dollars. And then we can see them both formatted as dollars here. The second thing I notice is that obviously when I'm running this, I'm seeing a minus number, -$1. What can that mean? So surely people can't have -$1 as a salary if these bank employees. And that's because we have special values that indicate that data is missing. This is very common. We have what are called user missing values. If I just hit Control X on this, if I just delete the first cell here, you can see that it just puts a full stop in. That's called a system missing value. That's just what it puts in for a number field when it doesn't have a number. It's just like a null. But sometimes you'll have actual special values here. If I sort this in order, say sort ascending, you see, look, there's 7 cases here. It's just -1. These are people with these are cases where they just don't know what their salary is for one reason or another. I can sort back in order of the ID. So that's going to affect the mean, obviously, because you've got a bunch of people here -1. So what you would normally do is you would assign, again, formatting, thinking about formatting, you would assign a value to this and say, I'm going to assign a discrete missing value of -1. Notice you can have up to 3. That's because in surveys, you tend to have things like refused as a missing value, don't know as a missing value, and not applicable as a missing value. And they're often coded as things like 99, 98, 97, or -99, -98, -97. Here, the values have been coded as -1, missing values. And if I rerun my descriptive statistics now, it says the minimum value is 15,750, the maximum value is 135,000, and it has affected the mean because we've taken out these -1s. They are no longer included. It has identified 7 missing cases. And the mean is now 34,450, whereas beforehand it was 33,941. So being able to, again, this is the importance of formatting the data, being able to format the data. And of course, I could give this a label like current salary. There's lots of other things there we could talk about. We could talk about like scale here, for example. It does make a guess as to the type of field it is. If I change this accidentally and set it as a numeric field, as a category field, as opposed to a number, as opposed to a continuous field, or a scale field, which is what a ruler is, then see the effects of this when I do descriptive statistics. It tries to give me percentages for each individual value because we're basically telling it that this field is actually a category, not a series of numbers, of real numbers. So again, this is why formatting the data is so important. So normally we'd learn a little bit about formatting and invest a bit of time and set the data up correctly, giving it appropriate labels, identifying missing values, identifying whether measure is incorrect, and just generally formatting it correctly until eventually you got it the way it should be. It should be formatted. I notice a birth date here has under date it has hours, minutes, and seconds, even though that's not even not a real problem, but it looks a bit weird. You can change the date format now. It looks a bit more natural. So you might change these things as you would normally do when you're working with data set, even if it's in Excel. You generally tend to reformat things and change things because it makes a difference to the analysis that you're doing. If, however, you've done that already, if you've done that previously, and you're working with a data set that maybe you work with on a regular basis, because you're doing monthly reports or something like that, it turns out that you can actually copy the data, copy the formatting from the previous time you formatted the data to the current data set, even if the values have changed, and the formatting can be copied over. And we would do this by going to Data, Copy Data Properties, and go to Browse. And here I've got a data set called Employee Just the Variables. It's not a special data set, it's just an earlier data set. And if I hit next at this point, it matches them by the ID field and says, well, if they're the same ID, I'm going to assume they're the same type of field. And I'm going to copy across all of these properties. And I'll just basically hit finish. And immediately, as soon as I do that, you can see everything is suddenly formatted. And one of the ways which we can see that the formatting has taken effect is because when I click on value labels here, you can see that these little labels pop up and disappear on things like job cat. You can see manager and clerical. Instead of the values 3 and 1 appearing in our output, we will see clerical and manager. So we've coded it. A minority, instead of 0 and 1, we have no and yes, as in are they in a minority group. Okay, so that's our first bit about, how we read data in and how we format data. What about doing an analysis on data? Well, you can see that actually I tend to right click on stuff quite a lot and just, and say, okay, let's just get some percentages out here. There are procedures which do this explicitly rather than these sort of quick and dirty procedures. These procedures do this explicitly. You can go to analyze descriptive statistics frequencies, and you could choose something like, let's say, gender and minority classification and say, okay, I'll have these and I'll have a couple of pie charts with them. You can play around with formatting a little bit and whether or not they're in ascending or descending values. You could add in some statistics like means and medians if that was appropriate. If you click OK at that point, it just reruns that and gives you these two tables. Notice it's just adding this output to the end of the existing output. So any sort of raw work that you've got there, it's just adding it to it as you're going along. You can edit these tables. You can play around with them. You can change the formatting of them. We'll see this later on, but you can get rid of them. I should point out here the difference between valid percent and percent that you're getting here. Well, actually, this is a better example, is minority classification. We can see that there is indeed a difference between valid percent and percent here. So valid percent is based on all the values which are not missing. So it's saying off the data where we know if they are in an ethnic minority or not, off the 471 cases where we know if they're in an ethnic minority group or not, 77.9% were non-ethnic minority and 22.1% were ethnic minority. There are 3 cases which are labeled, identified as missing. They don't actually have a label for them. See, they don't actually have a label. It's just picking up what's missing. And they represent 0.6% of the data. You could actually go into that and go into minority here and say, you know what, I'm going to add a label for the missing data. What was that actually? Let me just have a look again. What was the code for missing data? It was 9, code 9 for missing. Okay, so if I went here and I could add in just a little code to say 9, or say I could give it a label like unknown. So missing data can have labels as well. I'll rerun that. Oh, sorry. Minority classification. Let's run it again. I mean, see, it's now labeled as unknown. Interestingly, you'll notice there that minority classification has been set as ordinal. I don't think that's probably correct. We're set as nominal. I'm not going to go into the details between different levels of measurement, but suffice to say, there's a lot of information out there, and we do have training courses that talk about what are called levels of measurement. It refers to the type of field that it is, really, whether it's in this case, whether it's a category field, where they're just in discrete categories, where it's a ranking field, like a rating scale or satisfaction, and where it's a number field or a scale field, where it's like salary or beginning salary or something that we can take an average on, something that we wouldn't take percentages of. And in that, on that theme, if I wanted to look at the interaction between category fields like job cat and minority here, or job cat and gender, one way in which I might want to do that is to go to Analyze and down to descriptive statistics, and then down to crosstabs. Okay, so crosstabs are kind of the workhorse of SPSS. It's one of those powerful ways in which you can work with a data set and work with the application. And if I pick something like employee category and put that in columns, a minority classification, put that in rows, and I went to sales here, I could ask for rows, row percentages. Sales refer to the little boxes that make up the table. We click OK at that point. This is our crosstab that we produce. The term crosstab comes from SPSS. They're all often referred to as contingency tables. You can double click on them and play around with the formatting, etc. if you wanted to make this a wee bit more readable or whatever. Um, so you can play around with it. But you notice here that within the percentaging here is row percentages. So it's saying the percentage within minority classification. So it's saying 74.7% of those in non-minority group are clerical workers. 83.7% of those in minority groups are clerical workers. So we're taking percentages off minority groups here. So 21.5% of the non-minority, i.e. the white workers are managers, and only 3.8% of those in the ethnic minority groups are managers. If we wanted to swap the percentaging around, of course, we'd simply go to sales here and we'd change that to column percent and rerun it. And you can see now it says, well, okay, now it's 75.9% of clerical workers happen to be non-ethnic minority, and 24% happen to be ethnic minority. 95% of managers happen to be white ethnic minority, white group, and 4.8% tend to be in some form of ethnic minority as identified by this variable here. So the percentaging direction makes a lot of difference, and one might do a significance test here, like chi-square, to find out whether or not these differences that we're observing are, to use the term, statistically significant or not. And we'll return to that in a moment. But first of all, I just want to deal with a practical problem here. What happens if I wanted to compare, say, I don't know, minority classification by salary? I can't put salary in here because, as you'll see, it just looks mad. Yeah, I can't do that because it's because crosstabs are not for scale variables. They're for category variables. So what I might do instead is I might say, well, I'll compare the averages. So I'll go down to compare means and go down to means here and say, okay, I'm going to put salary up in this top box here and put minority classification into the independent box, which is the kind of the grouping box. Click OK. And that would tell me the mean salary for non-ethnic minority is $36,000. And for those in ethnic minority, it's $28,000. So there's a difference here, about $7,000 to $8,000, somewhere between that, between these two groups. But let's say we did really want to work with current salary as a category field. Well, it turns out that there's a procedure that we can work with. And this is where we get into manipulating and transforming the data. Procedure we can work with called visual binning, which makes this really easy. If I go to visual binning and call up current salary and click continue, you can see what it does is it scans the data and it shows me what the current salary distribution looks like. This is a histogram. You can get these with a frequency table as well in SPSS. And it's offering me the opportunity to create a new version of this variable, which I'm going to call sal band, or current salary binned here, as it calls it, binned or binning or banding, same meaning. I'm going to call it grouped. And what I'm going to do is I'm going to slice it as if it was a cake. And I'm going to say make cut points. And what I would normally do is I say I want 3 cut points with a width of 25% each. So it's a bit like getting a really complicated chocolate cake for a kid's party in the shape of a dragon or something like that. And you're trying to slice it, even though it's an odd shape, so that every child gets exactly the same amount. And here it tells me, it says, if you want to get as close to 25% as possible, then I'm going to slice it at $24,000, at $28,000, and at $37,500. And it turns out you can actually change these values. You can move them around. So this one here is the $28,000 slice, and I could move that about, and it would change it, see? So I could make it 29,000, or alternatively, I could double click in here and just change this to 29,000. And I might do that just to make it a bit more rounded. And here I might say, well, 37,000 is a bit of an odd 37,500 is a bit of an odd split, so I'll just make it 38,000. I don't care if it's not exactly 25% in each group. I just wanted to make sure there was enough cases in each group. This is really useful. And if I hit make labels at this point, it creates labels for me. So this would be, I could alter the label here, and this would be 24,000 or less. And this is, instead of 38,000, 1 plus, I could just change this to over 38,000. And then click OK at that point. It says, I'm going to create a new field for you. Do you want that? I say yes. And when I go back to the data set, it's created this new field called sal band. And now I run descriptive statistics on it. It shows me that there's almost 25% in each group, even though I've moved the values around. And now if I go back to crosstabs, you can see I'm using this little recall button here just to iteratively go back to a previous procedure. I can swap that out and put current salary in here. And I could say, okay, let's put what makes sense here. I'll have row percentages because I really want to compare the minority groups and minority and non-minority group. And I could ask for a clustered bar chart. Click OK at that point. And here it's saying, okay, well, look, 24% of the non-ethnic minority groups on 24,000 or less, 28% are on over 38,000. Of the ethnic minority group, 28% are on less than 24,000, only 7.7% are on over 38,000, So this crosstab's revealing some quite big differences here between the groups, particularly when we look at the highest earning category here. It's not surprising. Let's say that for whatever reason we wanted to remove one of these groups. Let's say we wanted to remove the custodial workers. There's 27 of them in this. Let's say we really only want to compare clerical workers and managers. I believe that in the original court cases it was about the clerical workers and focusing on discrepancies in their pay. So let's say I wanted to take them out. If I want to do that, then I'd go to data and go down to select cases. This is where we filter data. And I can go into a conditional box here and say, well, look, if employment category is equal to 1 or employment category is equal to 3, keep it. That's one way in which I could do it. So I can right click on it here, just very useful. Right click on it to see how they're coded, 1, 2, 3. So I can see the codes. Or alternatively, I could just say, look, if the employment category is not equal to 2, then keep it. That's the statement. So I'll say not equal to, or I could use I'll use the letters NE, not equal to 2, and say if job cat is not equal to 2, and what happens is it says it will filter out the unselected cases. Click OK at that point. We can see that if we scroll down through here, we start to see these little cases, these little strokes appearing through the case headers, indicating that they are not included. They are not selected. That's because, of course, they are custodial workers. We can check to make sure it's worked and go into descriptive statistics. And sure enough, in descriptive statistics, the data set can no longer see the clerical workers. They don't exist. And we could rerun the crosstab that we did earlier. And now the crosstab is just based on 438 cases, which are the people who are in the clerical and manager group. And we say, well, okay, comparing the differences in pay for clericals and manager workers in different ethnic minorities and taking out the custodial, do we still see the same differences? Well, yeah, we do, because we see that, off the ethnic minority group, only 8.8% of them are on over 38,000, whereas 29.7% of those in the white group are. Okay. So again, selecting data, very important, being able to filter data, being able to create new fields. There's other things you can do here with select cases. You could say, for example, I just want you to create a new data set for me and put that to one side, and I could call that managers and clerical, something like that. Managers clerical, and click OK. It would run that, and it would actually create a little data set here that called managers clerical. So it would literally just put it to one side. If you didn't want to keep that data set, you could just close it down, saying I don't want that, and then you could go back and switch off the filter by going to select cases and say select all cases, or reset if you like. Click OK, and you go back to selecting all the data again. And we can see this. We know that works because if I click on descriptive statistics here now, I can see the custodial workers are back again. So this is how we would define clerical workers. Now, when I've been, you see on me playing around there, crosstabs and playing around somewhat with the means table. So I'm just comparing averages. There are other procedures here, other modules I could use to do more complicated types of tabulation. I'm just going to quickly touch on one of the most popular modules, which is the custom tables module. If I click on that, and that allows me to create pretty much any type of table I want. You know, whether it consists of percentages or averages or medians or totals or whatever I want, and it draws out the table for us in a very visual way. So if I put gender and put that into rows here, you can see it's starting to draw the table for me. And I'm going to put employment category across the top. I could put minority group under that. So that's called stacking. Or alternatively, I could have it put on the side within it. That's called nesting. So minority classification. And I could remove the variable label if I don't need that. I could add things like current salary onto the end here and beginning salary. And I could do that kind of thing. I could add age on there as well. I could go here and say, okay, I want to go to categories and totals. I want to put a total in there. I want to relabel it because some people don't like the term total. Let's put the term base. And you could put that at the top so it appears at the top. So you're looking at the baseline. And I could click on here and say, okay, look, these are just showing counts. I want to change this count to, or add in something like row percentages or something like that. So I could put in row percentages and I want the label just to say row percent rather than row n percent sign. So I've got a lot of control over the formatting here. Close that. And I could pick, say, age here for whatever reason, just for illustrative purposes, and say, look, I want to turn that into, I want to show that as a median, not as a mean, for whatever. And I could apply that just to that selection or to all of the values in there. And then click OK. It's going to be quite a wide table. So we built a table of means and percentages. It's more for sort of report that we're producing here. We could actually double click on this and activate it and play around with it. I could click on here and say, look, create a little chart off that, and it creates a little chart off that for me, comparing just those two values. Or alternatively, I can go to format here and I can go to table looks. You can create your own table looks. I've got my own sort of table looks, but look, there's different ones that ship with the software. You can download them and set them up as new templates if you like. And say, I don't like that table look. So you can create your own house style. Very easy to do, actually. There's one, there's web report blue. I could change it to that. If you wanted to edit it and have it in your own style, you just basically double click on it and say, okay, I want to go to the formatting in here, creating the table looks, and go to the formatting and change that and say, okay, look, I want to edit the look. Here's the formatting, change the formatting to different colors or add in borders or whatever you want. You could put in, let's say, just for illustrative purposes here, I'll make this red, make everything a dotted line and hit OK. So, click OK at that point. So you can play around with these styles, add different borders, etc. to them, and save them away as a little file, which you can then choose from the edit options here as your default pivot table file. So here's my default pivot table file. I use one called Big Blue, which is larger font for teaching purposes. So playing around with the output, very important here as well. We're going to touch on statistical significance here before we finish up, just looking at some of the charting options. Probably the best example of introducing statistical significance. Here we were looking at minority classification against current salary. That was our last one. We were seeing some big differences here, of course, between between the payment groups in terms of current salary and people's minority classifications. If we wanted to test that statistically, we'd click on statistics and ask for chi-square. And we'll be going into this more detail in the next session at 1 o'clock. But suffice to say, if I run that, it gives me the same crosstab as before, but it's showing me a Pearson's chi-square value. And the Pearson's chi-square value is testing the null hypothesis. It's basically showing us the probability of getting a result as extreme as the one we'd observed, assuming in a universe, if you like, where minority classification had no impact whatsoever upon people's current salary. There was no relationship between them. And it's telling you how often you would see that in a universe where that was actually true. And it's basically giving us a number here, which is really, really small. In fact, if I double click on it, sorry, I clicked on the wrong thing. Yeah, it's a really, really small probability value here, 0.00001528 So, it's tiny as a percentage. If it was 0.05, for example, that'd be 5%. If it was 0.005, that'd be 0.5%, and it's less than that, less than 0.5%. And we would reject the null hypothesis on that basis. We would say that this probability value is too low to support the notion that minority classification is completely independent of current salary, that the two things aren't related in some way. In fact, if you double click on these bits I put here and click on what's this, it gives you a little definition. This is significance level based on the asymptotic distribution of the statistics. Typically, a value of less than 0.05 is considered significant. So it's less than 0.05. If I rerun this and change this and said, okay, let's look at that by gender. You get similar sorts of things with gender. Here I'm rerunning it and see that 48.8% of the female employees are employed on 24,000 or less, compared to only 6.3% of the males. 39% of the men are on over 38,000, compared to 6.1% of the women. And of course, again, that is much less than 0.05. And you could do stuff like, you could say, is there a relationship, or is there a relationship between gender and minority classification? You could actually do that and test that. Or you could group age into age group, just as we did with current salary, and say, is there a relationship between gender and age group here, to do further analysis. So you can do a lot of analysis with something like a crosstab when you're working with categorical data, because you can split things up. And if you start to combine that with things like filtering, and combine that with things like, being able to band variables, so you can take continuous variables and create groups of them, it starts to get very, very powerful in terms of, the types of analysis you can do. Now, I did mention we would touch on some charting here, so I want to just touch on building charts and chart editor. If I wanted to do like a representation, almost like a representation of a crosstab in a chart, I wanted to show it visually, then the first thing I'd probably go for is I would probably look at something like a stacked histogram, or sorry, a stacked bar chart. Stacked bar chart is one that looks like this. And you can see here that in the chart builder, what you got to do is you choose a chart from a menu, and you drag that up onto the canvas, and then you start to populate it with the requisite variables. So in this case, I'm going to put current salary. I'm going to put that along the bottom here. Actually, do I want to do that? No, I don't want to do it. I'm going to make that the color. I think it makes more sense to make that the color that I'm creating, and instead pick up gender and put that along the bottom. So now I've got two genders split by color. So the first thing is it's showing the count, not the percentage. You can change this even after you've created the chart, but if you wanted to change it to percentage, you could change the percentage here and set parameters and just say, I want this based on the total for each X category. And that will now be the percentage. It will stack. Secondly, the colors are very weird. So you might want to go to chart appearance and go to options here. You could go to your own user specified, your own templates. Again, you can download these from our website. We've created some templates that play around this stuff. You can see here I've got these different chart types I can use here, like legacy and stuff like that. There's one here I think I've got which I've got user specified. I think I've called it lollipop or something like that, which is kind of for banded variables. Let me just see if I can find this. I might just bear with me a moment while I look for this chart. Looks, let's say, let's go lollipop 5. That might do. You'll get the idea anyway. You can see it shades it sort of from green to red as a lollipop. If I click OK at that point, it's created this chart, and you can see that they're stacked to 100%. And we can see what proportion. I'd probably done it. I should have done reverse lollipop, where the higher the salary, the redder it is, really. But here it's saying what proportion of women are on the over 38,000 bracket compared to men. And you can see there's quite a big difference here as we're looking up through the different gradings, the different salary bands here. And in fact, you could actually right click and copy this. You could copy this as an image into Microsoft Graphics Object, or sorry, into Microsoft tool like PowerPoint or Word or something like that. Or you could copy it as a Microsoft Graphics Object. If I just let's see if I can skip out to. Let me just insert a new slide in here. I'll just go for a blank slide, and I'll go paste. So you can paste that as a picture. Or I can paste it. Should be able to paste it. I can paste it, see it as a Microsoft object. So that's the same chart, but I've pasted it into a Microsoft application as an object. And I could go to chart here. You can see I could change it and say, no, I want it like that. It recognizes really what it's doing in the background is it's pasting the data. So if you don't like the way in which the charts appear, you can paste them into something like Excel or PowerPoint or Word or something like that, and paste them as Microsoft objects, just by copy and paste as Microsoft object, and change the formatting and the appearance of it to your heart's content, and and probably get a much wider range of different sort of aesthetic styles that one could have at that point. Okay, so I've got some questions coming up here in the chat. Let's see. Um, okay, what's this? Yeah. Oh, the employee.sab does ship with SPSS. Yes, that's right. So you can get that. Yeah. So somebody's asking about, are there any data sets you can practice with? Yes. Yes. SPSS comes with a whole list, a whole folder of data sets called samples. Okay. It's where SPSS is installed. There's a whole bunch of them. You'll see them referenced all the time in help. If you go to help, you'll see it. It'll say there'll be like little tutorials and things like that under the topics, help topics and tutorials here. And the tutorials will reference a data set, and they'll say, for example, we're going to use this data set. It will be in the samples folder. The employee data set's quite well known, sometimes called the bank data set. You could just search for it online, you'd probably find it. But yeah, you can see here is a list of all the different data sets. You can get opening data files, etc., etc. So yeah, there's a lot of information there. Okay, we're coming up to the end here, so I think we've gone through all of the things we wanted to talk about. Let's just try to pull things together somewhat. There are some additional resources that you should be aware of. So SPSS FAQs, everything from finding out what you have installed on to how to merge files or change the language. So we've got lots of stuff about SPSS. We've got a whole raft of video guides, both on our website and on YouTube, that look at stuff like this, as well as little mini topics and how to reverse the scale and different ways in which you can recode data. And a little blog series on statistics called Eat Your Greens, statistical testing. We also offer a lot of services and expertise. We offer consultancy and help. This could be like anything, could be like a day's worth or through to, a longer engagement. It could take the form of training that we provide, whether it be on-site or remote virtual. It could be kind of working side by side with you, where we do some of the work and then we train you on how we did that. Or it could be helping with recruitment of staff. So we do a lot of helping with staff recruitment. You can manage your existing SPSS licenses with us. So we can help you manage your SPSS licenses. If you don't have to be a customer of Smart Vision, but we generally tend to be fairly flexible and easy to deal with because we're a smaller company. We're experts in SPSS. You can buy your analytical software directly from us, often with discounts, and we offer our own web shop. We offer no strings attached technical and business advice to anybody on all comers, and we offer formal technical support services around the SPSS product family. For our customers, Smart Vision Europe customers, gain free access to our library of training materials and recorded self-paced training courses that we have online. So there's a whole library of training materials there that we have that people can access and download for free. I do hope you find that useful. I'll just check the chat here. That looks okay. Yeah, okay. So it's just Rachel's been dealing with that.
Yeah, I've done the chat. There's one question in the Q&A.
Okay, where's that?
It's about data. So from your demo, it appears you can click on a cell rather than a column heading to format or code a whole column. And by clicking any cell in a column can sort the whole data set by that column. Have I understood that correctly?
Right, okay. I'm not clicking on the cell to do it. I'm clicking on the data header. That's the first thing. So I'm clicking on the data header, and I'm also double clicking on the header to take me to the formatting option here, which just shortcut jumps me to it. Clicking on the cell is for editing the values. Like here, if I wanted to change like this to 16, that is not the same as formatting it, okay? So if you want to format it, or if you want to, want to sort it or something like that, there's things you can do, but you really have to. Yeah, you can see here if I click on the cell, I can copy and paste and clear and hide columns and get variable information and do descriptive statistics. If I click on the header, it's slightly different. I can sort ascending and descending, and I tend to get into the habit of double clicking on the header to jump to that column's formatting location in the variable view. So
Perfect.
okay.
Thank you.
Okay, in the meantime, thanks very much. Do look forward to you logging in again in the near future. And bear in mind that we do have recordings of these webinars and many other webinars, both on our site and on YouTube. So you might want to check them out if you find this useful. In the meantime, thanks very much for logging in.